Hello, this is Mike Lyler from Northern Kentucky University, and I was having so much fun writing Chapter 4 of my book dealing with particles that I decided to write a planetarium. Turns out that, if you have like birds, bees, fire, smoke, or even stars, you can actually characterize them in terms of particles, and that's exactly what I've done. I took the panorama engine that we created earlier, hacked a particle field class, and created basically a star field or constellation field using Papervision and basically data that you can grab from the web from somewhere like Nomad or whatever. So this is a real star system. These are real stars in a sky map using celestial coordinates and using basically the DEC and RA coordinate systems that you find typically on any astrological site. So I'm going to show you how we made this, and to do that, let me bring up my Word document. Now you can find this full write-up on the book's blog, and let me give you some addresses real quick here. The book's blog can be found at professionalpapervision.wordpress.com, and all the files for this particular demonstration are on that site as well. Let me show you where those are at. So the demo site that you're looking at now is on www.professionalpapervision.com/demos/web/planetarium, and you can get the download, all the code, including the Papervision classes, from code.google.com/p/flex3cookbook1/downloads list, and you want to download and you want to choose Planetarium. So that's all the code, and go to the blog, read all the details, and we're going to go through those step by step right now. Now, the first thing you want to do in actually creating this system is get in the mindset that you're not a Papervision purist. You're going to hack. And so let's start the hacking process. There's two parts here to this particular hack. You're going to create a sky map class, and then you're going to create a main Flex application, which you're going to put the sky map into. So the first thing you want to do is basically open up Flex and create a project and call it Planetarium. And then go ahead and dump Cairngorm right into your Flex libraries folder. Now, you guys are going, boy, that's pretty tough. That's pretty high-powered stuff. And I build learning management systems, and I use Cairngorm all the time to do that. And so I'm going to use it here. So yeah, I admit, I just swatted a fly with an elephant, but at least I confessed it. So let's kind of take a look at that real quick. So if you go to the book's blog site and you click on video tutorials, down here there's a whole tutorial on MVC architecture. So click on that and you can learn all about Cairngorm and how to place that into Flex. And we are working with Flex today. So let me bring up my Flex project. And in the SRC folder under org Papervision 3D, under objects under special, there's a file called particle field. You want to click on that, and then what you want to do when it loads, you actually want to duplicate it. Basically, just make another copy of it. Go up and go File, Save As, and save it as SkyMap. And when you do, you'll have a project called SkyMap. Let's bring that up real quick. So we're looking at the new SkyMap duplicate of particle field. And the first thing you want to do is make sure you go to the public class and change that from particle field to SkyMap, and go down to the constructor function and change that constructor function to SkyMap as well. Then what you're going to do, you originally had some variables like a field width and a field height and a field depth. You want to get rid of those and actually put a radius in there. So make sure you declare a public variable, or make sure you declare a private variable, sky radius, and replace in your constructor function that length, depth, and width with sky radius. And there's my sky radius right there. And that way now you have a function that you can play around with, and it's a little different than what you had as far as particle fields are concerned. You're going to go down a little bit lower, and the whole deal, the way everything goes within this program is the way the particles are set into motion. So originally let me open this up real quick. So we're now looking at the original particle field, and what we want to do is we want to make sure that we change these randomizing functions. See, so you have an X, Y, and Z. They're all randomized, so it's just throwing the particles all over the place. What you want to do is throw your particles, your astrological data, out on a sphere. And so you're just going to change that to basically a spherical coordinate system, which uses the celestial particle coordinates as well. So back in SkyMap, that's exactly what we do. That's really all there was to this program. And here's my new coordinate system. and I have things in terms of basically a spherical system. A cosine times a sine, and a sine times a sine, and finally a cosine. And that's the spherical coordinate system. And then what you want to do, you want to parse all those particles in. Now, so basically you have an array that you've created. We call it particle number. That particle number is based on an array that comes in through Cairngorm. And so you can see we're bringing in those different array values. And pretty much it's basically 4 sets along the row. And you're just choosing, in a sense, modulars of 4. So let's go back and explain that a little bit. Let's take a look at the data, and let's show you how the data is brought into the system. But it's pretty much is all there is to the program. You're just bringing these sets of particles, throwing them on a spherical shell, and that shell obeys the principles of the data that you're dealing with. So let's go along and take a look at some of that data real fast. Okay, so what you're looking at now is actual star data, and so you have the RA number, and then you have the DEC number and what it is, and also its brightness and magnitude. So all those are brought in, 0, 1, 2, and 3 position, and then you basically increment that as you're putting the stars or throwing the star pieces, or I guess you would say the plasma stars out onto your, the particle stars out onto your spherical coordinate system. So that was fairly easy. The only other thing that was really neat about this is using Cairngorm. I'm going to show that to you real quick. In my folder right here, I'll call it org lively, I have a model and views. If you click on the model right here, I just had to create an array, and at the bottom of that array, see, it's basically a MyStarData array. So if I go back to the program, at the bottom I use a HTTP service command to bring in the star data, and then that goes to a result handler, and when you go to the result handler, what it does, it takes that basically an array, and it does a dot split on it, and it splits all that comma separated data into individual pieces and throws it into the MyStarData model locator, and then that's all there is to it. The rest follows basically just how we did the skybox example earlier in my blog post. And here's my sky map, and I'm putting a particle on it, and I have the number, and I have basically the particle size and the radius of the sphere. So there you have it. Control click on sky map. You can see here at the very bottom I'm using that model locator .MyStarData to throw all that data into an X, Y, and Z in that celestial coordinate system. Well, I hope you enjoyed this. This is Mike Lively from Northern Kentucky University.